In this video, we're going to look at evaluating some limits where we are trying to evaluate a limit at a point where the function is not continuous. So here, let's just jump into some examples. Here we're looking at the limit of x squared plus 2x minus 3 over x minus 1 as x approaches 1. And so what I would have in mind is I would like to do direct substitution. I would like to just plug this 1 in place of every single value x there. But if I tried to do that, I'm going to get a 0 in the denominator. And so that's bad news. Now, it doesn't mean that that limit does not exist. It might not exist, but it doesn't necessarily mean that. So here, what I might try to do is, let's see if we can factor the numerator. So here we have a limit as x approaches 1. That numerator, it factors into x minus 1 times x plus 3 over x minus 1. Those x minus 1s will cancel. And at this point in time, once we have canceled those things, now we can try that direct substitution. If we were to plug in 1 for the x into whatever remains, we're going to get 1 plus 3, which is 4. And that's how we go about canceling common factors and using that to evaluate limits. One thing that happens here that suggests to me that I might have some cancellation that occurs is when I thought about this direct substitution, if I plugged in 1 to the top, I would get 0 on top. I also got 0 on the bottom. And so that suggests to me that there might be some sort of cancellation that occurs. How we find that cancellation is, it can be different depending on the setting. All right, so let's look at the second example. Here we have a limit as x approaches negative 2 of x squared plus 3x plus 2 over x squared minus 4. If we tried direct substitution, again, we're going to get 0 over 0. So since that happens, let's first factor the top and the bottom. And so that top, it is going to factor into x plus 2 times x plus 1. The denominator, we have a difference of 2 squares. X squared minus 4 will factor into x plus 2 times x minus 2. Is there any cancellation that will occur? Absolutely, right? So x plus 2 and that x plus 2 in the denominator cancel. And so now we can try our direct substitution. Negative 2 plus 1 over negative 2 minus 2. And when we do that, we get negative 1 over negative 4, which is just 1/4. Great. So far, so good. That's how we might go about canceling out some common factors. Let's look at this last example here. Again, if we try direct substitution, we're going to get a 0 in the denominator. We'll also get a 0 in the numerator. That suggests to me that some sort of cancellation might occur. So we just need to go through some work to try to find that. And so we need to go through a lot of algebra. On the top here, we see one fraction minus another, right? So 1 over x plus 2 minus 1/2. So here we might go about getting a common denominator. So if we multiply the first one by 2 over 2, we'll have 2 over 2 times x plus 2 minus, multiply the second fraction by x plus 2. All over x. So this is a limit as x approaches 0. Now that we have a common denominator on top, we can rewrite that as a single fraction. So we'll have 2 minus x minus 2, so you'll just have negative x over x plus 2 times 2 over x, which we could write as a limit as x approaches 0 of negative x over 2x times x plus 2. We have some cancellation that will happen. That x and that x will cancel, leaving us with just a negative 1 on top. And if we do direct substitution now, we have negative 1 on top over 2 times 0 plus 2, which is negative 1/4. And that's how we can go about using cancellation and canceling common factors to help us evaluate a limit even when we have some discontinuities. Now, there are still other discontinuities or other methods that we might use. So in our last video, we mentioned 5 different techniques. So this one, we looked at our first technique, canceling common factors. In our next video, we will look at rationalizing numerators and denominators, and we will also look at using the squeeze theorem. All right, we will see you there.